Hello and welcome to Science Talk. I am your host, Jim Massa. In this video, I wish to share with you some interesting research done in the field of astrophysics. Some of you may or may not have heard of the detection of gravitational waves late last year. This has very important implications and it's very exciting, to be honest. So what happened here? Okay. Basically, there were several studies that were performed, and they found the existence of gravity waves, and they have been verified, and they've noted two different mechanisms by which gravity waves, for now, can be created. The first is through the case of black holes merging together. When two black holes merge together, they create the strong gamma ray bursts, which then, of course, can be detected. But there was also the actual detection of a ripple in the space-time continuum using very sensitive instruments. These were noted. A second mechanism is when two neutron stars collide. Now, when two neutron stars collide, they can also release gamma ray bursts, but oftentimes, as they have found with this study, was that there was a brief flash in the visible spectrum. So this can be a direct observation. Of course, there are instruments that will detect any electromagnetic radiation in any of the frequencies along the electromagnetic spectrum. Visible light is just one small, tiny portion of the electromagnetic spectrum. So, less than 2 seconds after detecting the gravitational waves, there were two satellites that were pointed at a particular spot in the universe, namely an elliptical galaxy that's designated NGC 4993, which is about 130 million light years away in the constellation Hydra. The researchers go on to state the observation of visible light in conjunction with gravitational waves is different from early examples of the ripples when observed from black holes merging together. So perhaps a different mechanism can be at work here. What are neutron stars, first of all? Neutron stars are the stellar remnants that occur when large stars blow up, when large stars go supernova. After such stars blow up and go supernova, the remaining cores collapse. If there's enough matter, it can collapse enough that the neutron star can itself become a black hole. If it's not above a certain threshold, then it becomes a very, very dense object. So, when two neutron stars collide, there's several possibilities that can happen. One is if the stars are small enough, they just make a bigger neutron star. Okay. But if the combined mass is above the threshold, then they can create a single black hole, and now we know release gravitational waves at the same time. Now, what's interesting to note is that Einstein, in his general theory of relativity, did predict the existence of gravitational waves. And he basically explained it as follows, that this is gravity acting to bend light as it goes around, say, massive objects in space and time, what became known as gravitational lensing. The solar eclipse of 1919 verified Einstein's hypothesis of the existence of at least gravity bending the space-time continuum. So that observation of that solar eclipse is what led us to consider the fourth dimension. We know about length, width, height, the three dimensions representing volume and our space around us, but now we have the added dimension of time. And Einstein's work on relativity predicted these the solar eclipse of 1919 helped verify that. Now, right now, okay, gravitational waves have been verified. They have different characteristics than, say, how light behaves. And we're still, this is brand new. We still need to figure out exactly what is happening here, what are gravity waves specifically. For a long time, there was a debate among the astrophysicists about the nature of light. Was light a wave? Was light a particle? And as it turned out, the answer is both. Light can act both as a wave and as a particle. And again, this is actually Einstein's work as well. Light, the scientists came to describe, traveled as a particle in packets called quanta, or in photons. Or it can travel as a wave. Now, to me personally, it will be interesting to see if something similar is the result of gravity. Does gravity also behave as a wave and as a particle? If there are particles, would it be called gravitons? Stay tuned. We don't know. This is all brand new. It's quite exciting. I will say this, though. The original Star Trek series, they had it right when it would show photon torpedoes, being shot out of the Starship Enterprise. It always showed it in the original series as a blob of light, not some like casket-shaped thing that we saw in latest series. And they were probably closer to the truth with that one. So the writers of Star Trek seem to have on the original series, had a pretty good pulse on things scientifically. I remember an episode where Captain Kirk talks about a black star. Now, this is before black holes came to be formally identified. So I thought that was kind of interesting. So, I just wanted to mention that, but there are other important considerations that go with this. Okay? And this involves when neutron stars merge. We now have evidence that when neutron stars merge, gravity waves are the result. But for many years, scientists have been able to explain the existence of the elements in the periodic table up to iron, which is about element 92 or so, if I recall correctly. And basically that's the result of thermal nuclear fusion reactions occurring inside the core of various stars. And then when the stars finally use up their fuel, they expand, contract until, if there's enough mass, they finally blow up, go supernova. And when they do so, the elements are spread throughout the cosmos. Carl Sagan famously said in his 1980s series Cosmo that we are just literally the stuff of stars. But what has not always been clear is how do the elements heavier than iron came to be? Well, there's evidence now that neutron stars may be the source for the heaviest chemical elements. Okay? And so, why is this? Okay? As I mentioned before, we know that stars fuse light atomic nuclei within the thermonuclear core reactions going on. It creates heavier nuclei, and they go boom, and they spread it. Researcher Hans Thomas Jankov at the Max Planck Institute for Astrophysics, located in Germany, he says, now we have the first observational proof for neutron stars mergers as sources. Okay. Basically, he says that there could very well be the main source for elements heavier than iron, such as gold and platinum. Now, I've already mentioned that neutron stars are extremely dense. In fact, really the only things denser than neutron stars themselves are black holes. Okay. So, along with this idea of neutron stars being the basis for heavier elements, researchers at UCLA, led by George Fuller, along with colleagues Alex Kosenko and Vladimir Takistov, offer yet another method by which stars could produce heavy elements. And that is, in essence, tiny black holes coming into contact with neutron stars. This is extremely interesting. Tiny black holes are speculative at the moment. They have not been directly observed. But in essence, what they describe in their model is that there's an interaction between these tiny black holes and the neutron stars, and the result is that there is an ejection of neutron-rich material resulting from when the black holes literally are carving out the inside of the neutron stars, literally eating the neutron stars from the inside out. And this abundance of neutron material, along with whatever existing protons and electrons that are floating around in space, this abundance help fuse together and form these heavier elements. So this is right now a working hypothesis. They are, of course, continuing their research into this mechanism that they're proposing. So it will be interesting to see where their research leads them to. This is what's wonderful about science. It's always the wonder of new discoveries and excitement, and either verifying a hypothesis or finding evidence that discounts the hypothesis, and we go on to rethink the issue. Related to gravitational waves, gravity waves have been detected in the sun's interior. This is the result of examining the rapidly rotating core. So scientists using the ESA NASA SOHO Solar Observatory have found long-sought gravity modes of seismic vibration, implying that the sun's core is rotating 4 times faster than the surface. This is just as seismology reveals the Earth's interior structure by the way in which waves are generated by earthquakes. Right? We have the P wave and then following it by the S wave, the primary and secondary waves. And using that, we can tell where the earthquake took place, the direction of travel, the intensity, etc. So, solar physicists are using helioseismology, helio prefix meaning sun, to probe the solar interior by studying waves, sound waves, reverberating throughout the sun. So this is quite interesting, quite exciting. In other astrophysics news, I want to turn my attention to the possibility of life on other objects. Okay. On Titan, Saturn's moon, vinyl cyanide has been detected and identified and verified. Vinyl cyanide is a complex organic molecule. But what's really interesting is that vinyl cyanide has the capability to form cell-like membranes, or cell membrane-like structures. So, a little background on Titan. Titan is larger than our own moon. It's larger than the planet Mercury. It's the only moon that has an atmosphere, and its atmosphere is quite dense, typically nitrogen and methane. The atmospheric pressure is actually 60% greater than Earth's. So what does this mean? Let's say you're in a public swimming pool and you go to the bottom of the pool at the deep end. The pressure you feel on your skin at that location is about equivalent to the atmospheric pressure on Titan. Titan does have liquid fluids on its surface, but it's so cold, minus 290 degrees Fahrenheit, that obviously it can't be water. What these rivers, lakes, and seas are made of, basically liquid ethane and methane. Now, Just like water here on Earth will evaporate, leading to clouds and precipitation and so forth, the same mechanisms are at work on Titan. There'll be evaporation of the ethane and methane, and they'll form clouds, and the precipitation will result in methane and ethane falling back to the surface of Titan. And by the way, ethane and methane are the two simplest hydrocarbons that can be found. The chemical formula for methane is CH4, so you have one carbon atom, where ethane is C2H6. So you have two carbon atoms comprising the ethane molecule. And in both of those cases, if you replace one of the hydrogens with a hydroxyl, an OH, not to be confused with the hydroxide ion, this is hydroxyl, it's an organic group, then you get respectively methanol and ethanol. Methanol you don't want to drink, ethanol is what we enjoy. The postulation is that the methane pools on the surface are the kind of environment that could help vinyl cyanide molecules link together to form these cell-like membrane structures. The researchers go on. Maureen Palmer, who was the lead study author, researcher at NASA's Goddard Space Flight Center, Dr. Palmer goes on to state that the presence of vinyl cyanide in an environment with liquid methane suggests the intriguing possibility of chemical processes that are analogous to those important for life on Earth. In addition, Titan is thought to have an internal liquid water ocean. Okay, so we just said it's too cold for water on the surface. Internally, through the gravitational forcing from Titan, on Titan from Saturn itself, could keep water in a liquid state. Just like, on Europa, tidal forces of Jupiter acting on Europa is thought to have, underneath that icy surface, to have liquid water. Also Enceladus, which is another one of Saturn's moons, is also thought to have internal liquid water ocean. All of these places, Europa, Titan, Enceladus, are good candidates for the possibility of finding life there. Now, the life could be simple single-cell organisms. It could be bacteria. They could be perhaps maybe simple eukaryotic, like protista-type cells. We don't know. It's all speculation, but they are good candidates for such studies. Related to possible exobiological life, new studies have indicated that ancient Mars likely had deep-sea hydrothermal vents. It is thought that Mars used to be covered by water. Okay. Observations by NASA's Mars Reconnaissance Orbiter, MRO, shows evidence of ancient seafloor hydrothermal deposits within a basin known as the Eridania Basin. The Eridania Basin is found in the southern hemisphere, and these deposits there are believed to have been formed due to volcanic activity in the planet's crust at the bottom of the basin, probably early on in the planet's history. Study team members think that hot, mineral-laden water pumped directly into the ancient Martian Sea, which probably held 10 times more water than all of North America's Great Lakes combined. That is a lot of water. Now, why is this important? Right here on planet Earth, we have deep-sea hydrothermal vents. The Juan de Fuca Ridge, for example, off the coast of British Columbia, is a deep-sea hydrothermal vent. And you go down there and you have what oceanographers call black smokers. And these are locations where there is hot water bubbling out from under the crust. It is rich in minerals. Now, because of the pressure, the water is superheated but does not boil. It stays in liquid state because of the pressure. Nearby these smokers, you will see the tube worms and other organisms. Inside the tube worms are symbiotic bacteria that are chemoautotrophic. What does that mean? We are familiar with photosynthesis. You have the chlorophyll found within the cells of plants. The chlorophyll attracts light energy. The light energy activates what's called an electron transport chain mechanism. And from there, using CO2 and water, the plant will produce glucose, which can then be combined to form structural polysaccharides or sucrose, maltose, what have you, for energy purposes. And in the process of doing so, the plants release oxygen, which we all breathe. Well, ancient Earth did not have an atmosphere full of oxygen. So how did life come about? It is postulated that life began in the deep sea hydrothermal vents, where the autotrophs do not need light energy to create their own food. They simply need chemical energy. Depending on the species of the autotrophs, they can use hydrogen sulfide. They might use some other compounds, typically to have a hydrogen and a sulfur aspect to it, or a nitrogen aspect to it. And from there, they produce their own food. And we see at these hydrothermal vents, very distinct little mini ecosystems. So if that can happen, if the mechanisms are in place where that not only did happen on Earth, but continues to happen on Earth, it is not unreasonable to consider the possibility that such processes might have also occurred on Mars. Very, very exciting. So that brings me to the end of this particular video of bringing you some of the news from the world of astrophysics and astronomy. Please go to patreon.com/Science Talk for Jim Massa. I hope you support this work. Spread the word. Thank you.